I mentioned we could animate in the canvas as well, so let's close up this document and open up another one to try out animation. Our last one, number 5, try canvas animation, I'll open up in the browser and in my TextEdit application as well. In order to create canvas animation, you need a few things set up in your file. So I've actually started this file out with quite a bit of script already. So I'd like to go through each piece so we know what's going on. First of all, I do have a canvas added, and it has an ID of animated, and I've added a border to it just so we can see the extents and how big it is. Down in the script, though, you can see that I've got a lot of things started out. So let's go through each one. At the top, I have a function called Window Request Animation Frame. Now, this is the key to animation with Canvas. What we're basically doing with this function is we're asking the browser window to give us a frame, we're going to paint animation into it, and the browser will take care of playing the animation back. You'll notice when we call for an animation frame, we have to do so with different requests for each one of the browsers. We've got WebKit here, Moz, O for Opera, and even Microsoft browsers handled. So this function will have to be there in order for us to be able to do animation at all. Luckily, you can just copy and paste it as is if you want to create a new animation file. So we've got this function up here ready to be able to request an animation frame. Let's go down a little bit lower and we'll look at what else we've got. First, I'll skip all the way to the bottom. We have a window onload event function, and it just says to animate. And as we've seen before, this function gets called as soon as the window's loaded up and all the elements are ready to go. So this will be the first thing that gets called in our program. And of course, we can see the animate function right here. At the top, we might recognize that. That's where we're setting up the canvas variable and the context variable so we can do all of our drawing. The animate function basically represents what happens in each frame of our animation. So the first thing that's always going to happen is we'll clear the canvas. We have to erase the last thing that was there so that we can draw new items onto the canvas. Then we have to draw the next frame of the animation. And then this is where we call our first function up at the top, request animation frame. So to kind of summarize, when our document first loads up, we call the animate function. That sets up our canvas for drawing, clears the canvas, draws a frame, and you can see it actually requests the next frame of animation, so it happens over and over again. Now, all the pieces that I've added so far are the basic mechanics, but the actual animation is what's going to happen right in here, and that's what we're going to add. To get things started, let's make our animate function draw something. I'll add a line right down here in the draw the next frame area, and let's just go ahead and set up a normal filled rectangle. I'll start with a begin path call. Of course, we start with context, since that's our variable. And then I'll just simply draw a rectangle and fill it. We'll use context rect, and I'll just draw a rectangle starting at 0, 0, the top left corner, and we'll make it 100 pixels wide and 100 pixels tall. Of course, I want to be able to see it, so let's create a fill style, and I'll just set that equal to blue. And of course, we need to call our fill function in order to draw it. Now what we've got so far is okay for drawing the rectangle, but it's not a very good animation. We can at least test it and see if everything's working so far. So I'll save my changes, and we'll go refresh our browser. And we can see that our rectangle gets drawn up here in the top corner, just like we wanted. Now we actually have created an animation, but it's kind of a boring one because what our animation does is comes through and every frame draws the exact same square. So it doesn't look like it's moving at all. What we need to do is add some movement to it. So let's set it up so that we can move this square in the X direction across the canvas. To do that, I would change the first coordinate of where we're drawing the square. And what I'd like to have happen, I'd like to start drawing at one location on the screen, and then just add a few pixels each frame so that we create the movement. Well, that'll be best done by replacing this 0 with a variable. So let's create a variable called xloc, short for X location. Now, of course, I need to define this variable, and I want this variable to exist outside of this function. So I'm going to go all the way up to the top of my script window, and I'm going to define it right there. We'll use my var keyword, and we already named it. It's called xloc. And let's set the initial value equal to 0. That way, the first time we draw the rectangle, it'll be up here in the left-hand corner at an x of 0 like we started. Now all I'm going to do different is every time we draw the frame, I'm going to take the old value of xloc and add 1 to it. We could simply write that longhand, xloc equals xloc plus 1, or we could use one of our special operators, like plus plus for instance. That'll add 1 to it as well. Now, each time the animate function called, we're going to add 1 to xloc, and it'll just move a little bit further down the line. Let's save our changes, and let's see what we have now. I'll refresh our page, and now you can see that the square is slowly moving. Each frame of animation is moving it 1 pixel further, and it actually keeps going until it's fully off the canvas. In each browser, the frame rate is determined by the request anim frame function up here at the top. So if we wanted our object to move faster, we would just add more to it. I'll change the plus plus, and I'll use plus equals this time. That's another special operator that will add on to our original item. And I'll add 5 pixels to it each frame. Now when I save the changes, and we update the page, the square's moving a lot faster. We can also update other elements as well as we change the animation. For instance, if I wanted it to fly down at an angle and add some y value to it, I simply just need to change that y value as it's going in. We could go up here at the top and create a variable for our y. I'll just make sure to call it yloc. Then down where we're drawing the frame, I'll make an update to yloc as well. We'll do plus equals 2 so it doesn't move quite as much. Then, I'll make sure to use the yloc variable inside of our rectangle drawing function so that it'll be moved to the new location each time. Let me save our changes, and let's see what we've got now. Now we've got the square animating in both an x and a y direction as it flies down and off the canvas. Now since we've added some motion, we can go back to our code and take a quick look at one portion of our code that I had already set up in the beginning, and that was the clear the canvas portion. This one line here will clear the entire canvas from beginning to end. You can see we start at the top left corner, and by using the canvas width and height properties, it makes sure that we cover the entire canvas this way. Now, what if we didn't clear the canvas? Let me just comment out that line and save that change, and let's see how our animation runs without a clear. Now you can see it's almost like I'm making a line across the screen, and what's happening is we're drawing the first square, but we're not erasing it. We're simply drawing another square on top of it, and then another square, and then another square. And this shows us exactly what's happening in the animation. By adding the clear in there, we remove the last frame, and then it looks like the square moves instead of drawing a big thick line like this. So let's go put it back. Now the nice thing about this type of animation is we have the full power of JavaScript at our disposal here. We can modify any property of that element, redraw it, or draw any other element we want. Just as a small example to show how we can work with this, I'll add a little if statement in here to check and see if our square has reached the other side of the canvas or not. Now if we look at where our canvas was made up here at the top, we have a width of 500. And our square is 100 pixels wide. So what we want to do is let's check and see if the xloc has reached 400 yet, which would mean it reached the other side of the canvas. I'll go right in here to our draw section, and I'll write an if statement. We'll say if, we need our parentheses for a condition, and we'll say xloc. If the xloc is less than 400, then that would mean it hasn't reached the other side of the canvas yet. Let me put braces on for my if statement, and I'll take these two update elements and we'll add them inside of the if statement. Let me clean up my indents so we can read it nice and easy. And here's how my draw statement's going to go. If our object is still on the canvas and hasn't reached the right-hand side yet, we'll go ahead and add 5 pixels to the x and 2 to the y, which will make it look like it moves. But if my xloc is not less than 400, which means it has reached the other end of the screen, we won't do either of these two things, and it'll appear as though my square's stopped moving. Let's save our change, and let's try it out. There's my square flying across the screen, and you can see when it reaches this edge of the screen, it's stopped instead of flying off the canvas entirely.